Imagine the most powerful military force humanity has ever built. Imagine a nation that spends more on defense than the next 10 countries combined. Now imagine that all this power, all this technology, all this global projection capability can be challenged by a single number. 350 seconds. That's how long it takes the Russian 3M-22 Zircon hypersonic missile to cover its maximum operational range. 350 seconds, not minutes, seconds. And within those 350 seconds, the strategic logic that has underpinned American naval supremacy for 80 years begins to crumble. Defense analysts and military strategists in Washington are only now beginning to articulate what this number means for the future of American naval power, and by the end of this video, you'll understand exactly why this implication shifts the balance of power for decades to come. But before we understand what this number means, we need to understand what's at stake. The American aircraft carrier isn't just a ship. It's a symbol, a statement of strategic intent that no diplomatic speech can match. Since the end of World War II, when naval aviation proved decisive in the Pacific, the aircraft carrier has become the central instrument of American foreign policy. Whenever a crisis erupts anywhere on the globe, the first question American presidents ask remains the same. Where are our aircraft carriers? This isn't rhetoric, it's operational doctrine. A carrier strike group isn't a ship. It's an ecosystem of warfare. At its center is the aircraft carrier itself, a floating fortress 330 meters long, displacing 100,000 tons, carrying an air wing of roughly 70 aircraft. Surrounding it, a Ticonderoga-class cruiser equipped with the Aegis combat system. 2 or 3 Arleigh Burke-class destroyers, also Aegis-equipped. A nuclear attack submarine operating silently in the depths. A supply ship to keep the group operational for months without returning to base. The cost? A Gerald R. Ford-class aircraft carrier runs about $13 billion. The entire group, with the escorts, the air wing, the submarine, the logistical support, comes to roughly $25 billion. The United States operates 11 of these groups. 11. It's a number unparalleled in military history. No other nation has even come close. And this is no accident. It's deliberate policy. The aircraft carrier has been the instrument that allowed the United States to project power into any corner of the world in a matter of days. It's what made the 1996 Taiwan Strait crisis end the way it did when Bill Clinton sent 2 carrier groups to the region and China recalculated its options. It's what kept the Persian Gulf under American influence through decades of regional tension. The mere presence of a carrier strike group on the horizon resolves crises without firing a single shot. That is the logic of the aircraft carrier. Not just to fight, but to prevent conflicts through the credible threat of overwhelming power. 80 years of absolute naval dominance. 11 strike groups, $25 billion each, and 350 seconds. In January 2023, the Russian frigate Admiral Gorshkov set sail on its first combat patrol, carrying a weapon that no surface ship had ever operated outside of testing, the 3M-22 Zircon hypersonic missile. Far from being a prototype, this was an operational deployment. The Zircon had reached the fleet. To understand why this matters, we need to retrace the trajectory of this system. The development of the Zircon began around 2011 as part of a broader Russian hypersonic missile program. The first tests were announced in 2017. In 2020 and 2021, confirmed tests demonstrated real hypersonic capabilities. Not PowerPoint slides, not unverified claims, but documented flights that confirmed speed and range. In 2022, Putin publicly announced that the Zircon was ready for deployment. In January 2023, the story became operational. The technical parameters are as follows. a speed of Mach 8 to 9, the equivalent of between 9,800 and 11,265 kilometers per hour, an operational range of approximately 1,000 kilometers. A sea-skimming terminal phase, the missile descends to extremely low altitudes in the final moments of flight, making radar detection even more difficult. A guidance system that combines inertial navigation with an active radar seeker in the terminal phase. Now the 350 seconds. If the Zircon is launched from its maximum range of 1,000 kilometers and travels at Mach 8 to 9, the total flight time is approximately 350 seconds, less than 6 minutes from launch to impact. That would be alarming enough, but that is not the truly critical number. It's the other one, the radar horizon of an American destroyer. The maximum distance at which its systems can detect a sea-skimming target is approximately 40 kilometers. In the terminal phase, when the Zircon descends to this skimming altitude, roughly 40 kilometers remain until impact. At Mach 8, 40 kilometers are covered in about 14 to 17 seconds. 14 to 17 seconds. That is the time the defense systems of the carrier strike group have to detect, track, evaluate, allocate, fire, and intercept a missile traveling at over 9,000 kilometers per hour before it hits its target. Compare it to what came before. The French Exocet missile, which sank the HMS Sheffield in the Falklands in 1982, traveled at Mach 0.9, subsonic. The operators on the Sheffield had minutes of warning. Minutes weren't enough. The Russian P-800 Onyx, a more advanced generation, travels at roughly Mach 2.5 and offers perhaps a 60-second response window at operational range. The Zircon gives you 14 to 17 seconds in its terminal window. The question now isn't whether American defense systems are sophisticated enough. The question is whether 14 to 17 seconds is physically enough time for any system to work. There is a distinction that needs to be made precisely here, because it changes everything in the analysis that follows. The Zircon isn't simply a faster missile. It operates in an entirely different physical regime. Above Mach 5, physics categorically changes. Air friction becomes so intense that the air surrounding the missile ionizes. Electrons are stripped from gas molecules, creating what engineers call a plasma sheath. The missile is effectively wrapped in a cloud of ionized gas that can reach temperatures of several thousand degrees Celsius. This plasma sheath has direct operational implications for both sides. For the missile, it partially complicates the operation of its own active radar seeker in the terminal phase. The ionized gas interferes with radio frequency transmissions, creating a window of partial blindness at the moment of closest approach. Russian engineers have developed solutions for this: communication windows between plasma pulses, alternative guidance modes. The problem isn't fatal for the missile, but it is a real technical factor. For the defender, the plasma sheath poses a different and much more severe problem. It alters the projectile's radar signature. A hypersonic missile in its terminal phase doesn't produce the radar return that tracking systems were designed to classify and follow. The signature is distorted, the flight profile is different, and the combination of extreme speed, sea-skimming altitude, and an altered signature creates more than just an interception problem. It creates a tracking problem. In plain English, carrier strike group radar systems may struggle to lock on and maintain a firm track of a terminal phase Zircon with the consistency required for interception calculations. Add terminal maneuvering to the mix. At hypersonic speeds, a missile can execute lateral evasions that generate g-forces no interceptor missile was designed to match. The physics of movement at Mach 8 means that a course change of just a few degrees translates to lateral shifts of hundreds of meters per second. An interceptor fired on a collision course calculated for the Zircon's original path might find the Zircon somewhere else entirely when it reaches the engagement zone. So, just to establish where we are before we dive into the defense autopsy, the Zircon doesn't just arrive faster, it arrives with a different signature, on a different profile, with maneuverability that current interception systems weren't designed to match, and with a response window of just 14 to 17 seconds once it breaches the detection horizon. What happens when you run every layer of the Carrier Strike Group's defense against this physical reality? The Carrier Strike Group does not rely on a single line of defense. It's a system of concentric layers, each designed to eliminate threats before they reach the next layer. Defense analysts describe this as defense in depth. Let's examine each layer honestly. The outermost layer is the Combat Air Patrol, FA-18 Super Hornets, guided by the airborne radar of the E-2D Hawkeye, operating at distances up to 400 kilometers from the group. Theoretically, they are the first filter, intercepting a threat before it even reaches the range of the group's missile systems. The challenge with the Zircon is geometry and time. For an FA-18 to intercept a hypersonic missile, it needs to detect the launch, vector into intercept position, and fire its own air-to-air missile at a favorable geometry. At speeds of Mach 8 to 9, the Zircon is in and out of an FA-18's engagement window in seconds. The most advanced air-to-air interceptor the Super Hornets carry, the AIM-120 AMRAAM, has a top speed of roughly Mach 4. Mathematically, the fighter engagement window against a sea-skimming hypersonic missile exists, but it's narrow, highly dependent on precise positioning and early detection, and far from guaranteed in real combat conditions. The second layer is the Aegis combat system with SM-6 missiles. Here the argument gets more interesting because the SM-6 has actually been tested against hypersonic targets. The SM-6 Block IA has an engagement envelope rated for threats of Mach 3.5 and above, real progress compared to previous generations. But the Zircon hits Mach 8 to 9. Tests in 2021 and 2022 showed interceptions under controlled conditions. But controlled conditions mean known geometry, predicted trajectories, and targets that weren't executing evasive maneuvers. A Zircon in actual combat doesn't offer those conditions. The SM-6 also has geometry limitations. It needs to be fired with enough time to reach the interception zone, which with a 14 to 17 second terminal window is a severe timing hurdle. And the subsequent layers make the picture even more grim. The SM-2 and the ESSM, the third and fourth lines of defense, were designed for subsonic and low supersonic threats. Both have engagement speed limits that put them in technically challenging territory against Mach 8. The SM-2 was not conceived for hypersonic speeds. The ESSM is a last resort point defense system, not a solution engineered for hypersonics. And then we get to the Phalanx CIWS. Pay close attention to this detail because this is where the analysis becomes particularly revealing. The Phalanx is the last resort. It's an automated close-in weapon system, a 20mm cannon firing 4,500 rounds per minute, radar-controlled, designed to destroy threats that have slipped past all other layers. It is literally what fires when everything else has failed. The Phalanx was designed for subsonic and low supersonic threats. Its rotation rate, its tracking speed, its ability to calculate firing solutions, everything was engineered for speeds in the Mach 1 to 2 range. At Mach 8, a projectile covers the Phalanx's maximum range in a fraction of a second. The engagement window, the time the target is within range and can be tracked steadily enough for effective firing, collapses to something at the absolute limits of the system's mechanical viability. But there is a greater vulnerability that transcends the individual capabilities of each layer. Every Arleigh Burke-class destroyer carries a finite number of interceptors. The vertical launch system holds 90 to 96 cells, filled with a mix of SM-2s, SM-6s, and other missile systems. If an attacker launches not one Zircon, but 5 Zircons simultaneously from slightly different directions, the carrier strike group must allocate multiple interceptors for each threat, because the interception probability of a single shot is never 100%. 2, 3 interceptors per target. 5 targets. We are already talking about 10 to 15 interceptors spent in a single volley. And the attackers can launch another volley. And another. At some point, the magazine runs dry. The most powerful carrier strike group in the world runs out of interceptors before the attacker runs out of offensive missiles. That is the mathematics of saturation. And it leads directly to the next dimension of the problem. This math goes beyond theory. It proved devastating 40 years before any Zircon even existed. On May 4, 1982, in the South Atlantic, a single Exocet missile launched by an Argentine aircraft struck the HMS Sheffield, a British guided missile destroyer. The Sheffield sank. One missile. One ship. The entire world had to recalibrate what naval defense meant at the end of the 20th century. The Exocet cost approximately $200,000 per unit at the time. The HMS Sheffield cost £30 million. The economic logic of the anti-ship missile attack had never been clearer. And 40 years later, with technology orders of magnitude more advanced, that logic has become even more extreme. The Zircon has an estimated unit cost of between $1 and $2 million, a contested and likely underestimated figure for mature production versions, but one that serves as an order of magnitude baseline. The target is an aircraft carrier that cost $13 billion. The ratio between the cost of the projectile and the cost of the target is approximately 1 to 6,500. But the asymmetry doesn't end there. The SM-6 missile, the most advanced American interceptor against hypersonic threats, costs approximately $4 million per unit. The Zircon it must intercept costs $1 to $2 million. Every defense costs more than every attack. In a saturation campaign of 20 Zircons launched against a carrier strike group, the cost of the interceptors needed to attempt a defense could reach $80 to $120 million or more. The attacker spent $20 to $40 million. The economic logic of the attack is unmistakable. In a missile war of attrition, the defender structurally spends more than the attacker, and the defender is protecting a $25 billion asset that cannot be replaced in weeks or months. This calculation has not gone unnoticed. Documents from the Pentagon and testimonies before Congress openly acknowledge the problematic exchange ratio between offensive missiles and defensive interceptors. The characterization circulating within American strategic planning circles is blunt. The exchange ratio between hypersonic attack missiles and defensive interceptors is catastrophically unfavorable for the United States in saturation scenarios. Catastrophically unfavorable. These are not the words of independent analysts or external critics. These are the words of the American defense establishment itself. And if the United States recognizes the problem, the question is, what platforms are delivering this threat? And where on the map is it happening? Before getting to the American response, we need to understand the geographic scope of the problem. Because the Zircon is not confined to a single type of launch platform. The Admiral Gorshkov frigate was the first, but it will not be the last. Russia has 4 frigates of this class in service, with more under construction. Each one can carry the Zircon, but frigates are surface platforms, visible, trackable, detectable by satellites, and long-range aviation. They represent the easiest layer to monitor. The truly stealthy threat is the submarines. The Yasin-class nuclear attack submarine is one of the quietest platforms currently in operation. Developed as the successor to the formidable Soviet-era submarines, the Yasen combines near-silent operation with the capacity to carry up to 32 cruise missiles, a mix of types that can include the Zircon. It can operate for months without returning to base, at depths that make it extremely difficult to track by conventional means. What does a Yasen with Zircons do to the defense geometry of the CSG? It eliminates one of the few advantages the group still had. With surface platforms like the Gorshkov, the carrier strike group has at least the theoretical possibility of early detection, locating the ship, monitoring its positioning, having some notion of where and when a launch might occur. With a Yasen operating silently in the depths of the North Atlantic or the Barents Sea, that advantage disappears. The launch could come from anywhere within an area of several million square kilometers, with no prior warning beyond the exact moment of the shot. Now look at the map. Yasens and Zircon-equipped ships can operate in specific areas that create what strategists call A2 Anno Domini zones, anti-access, area denial zones. The Barents Sea and the Norwegian Sea, the approaches to the North Atlantic, the Baltic in certain operational contexts. These are areas where the combination of the Zircon's range with plausible submarine positions creates an envelope in which a carrier strike group cannot operate without accepting existential risk to the entire group. The strategic impact is straightforward. There are now parts of the ocean where sending a carrier strike group is, in practice, an unacceptable risk in a high-intensity conflict against Russia. These are the new no-go zones of the global naval map. And if the United States knows about the threat and understands the geography, what are they actually building to respond? It would be intellectually dishonest to present only the problem without presenting the answer. The Pentagon is not ignoring the hypersonic threat. Let's examine what is being done, with the exact same precision we applied to the threat analysis. The most directly relevant program is the Glide Phase Interceptor, the GPI. It's a system designed specifically to intercept hypersonic glide vehicles, the broader category that includes Zircon-type threats. The program is in active development. The initial operational capability date is slated for the late 2020s, with more realistic estimates pointing to the early 2030s. This is relevant because the threat exists right now, in 2023, with confirmed operational deployment. The GPI closes the gap somewhere between 5 and 10 years into the future. The SM-6 Block IA, as we mentioned, has demonstrated capabilities against hypersonic targets in testing. This is real, genuine progress. But demonstrating capabilities in tests and solving the problem in actual saturation combat are very different claims, and the American defense establishment is honest about this distinction in internal testimonies. The DDG-X program, the next-generation destroyer that will replace the Arleigh Burkes, includes provisions for directed energy weapons, high-power lasers for close-in defense. The physics of a laser traveling at the speed of light and causing damage through heat accumulation is genuinely promising for hypersonic threats. The major limitation is that the DDG-X is a program measured in decades, not years. In terms of official acknowledgement, General Mark Milley, when he was chairman of the Joint Chiefs of Staff, testified before Congress that American adversaries had developed a completely new type of weapon that is a threat to national security. The 2022 National Defense Strategy uses explicit language regarding hypersonic threats from peer rivals as a central challenge for which responses must be developed. This is the very American defense establishment publicly validating the analysis we are doing here. American offensive development is also moving forward. The Long-Range Hypersonic Weapon, or LRHW, is the American hypersonic answer, but it is an offensive weapon, not a defensive solution to the aircraft carrier problem. Having offensive hypersonic capability creates strategic parity in a major sense, but it doesn't protect a carrier strike group from Zircons. The honest answer is this: the United States is working on the solution. They are investing billions. They are developing real solutions. But the solutions have timelines that stretch to the end of this decade and beyond. The threat exists now. The gap between the current threat and the future response is real, publicly documented by the American government itself, and has immediate operational implications for how and where aircraft carriers can be used. The word obsolete in the title of this video needs to be defined with precision, because it doesn't mean what sensationalist headlines usually imply. The American aircraft carrier is not going to the bottom of the ocean. None are being decommissioned. The 11 strike groups remain operational. In dozens of scenarios around the world, operations in low-threat environments, shows of force against lesser powers, humanitarian operations, power projection in regions without advanced hypersonic capabilities. The carrier strike group is as effective as it has ever been. What changes is the geography of its maximum utility. The best historical analogy is the battleship after World War II. The battleship wasn't destroyed by aviation at Pearl Harbor, and midway, it was structurally displaced from its primary role. Battleships continued to serve as fire support platforms, as symbols of naval status. The USS Missouri and USS New Jersey participated in conflicts decades after Pearl Harbor. But no one considered the battleship the decisive instrument of naval conflict anymore. That role had migrated irreversibly to the aircraft carrier. The parallel isn't hard to see. In specific scenarios where geographic constraints weigh heavier, the picture is clear. A contingency in the Taiwan Strait would involve the carrier strike group operating within the range of a combination of Chinese systems, the DF-21D, an anti-ship ballistic missile with a range of 1,500 kilometers, the DF-26, an extended-range version, and the YJ-18, a supersonic anti-ship cruise missile launched from submarines. This multi-layered threat envelope would create a scenario where any CSG positioned for close combat operations would be at serious existential risk. In an Arctic or North Atlantic scenario, exactly the waters patrolled by the Gorshkov and the Yasen, the geometry is even more unfavorable. The most profound shift is in the deterrence equation. The logic we saw at the beginning, the aircraft carrier resolving crises without firing a shot, depended on an implicit condition that the adversary believed attacking the group would be suicide. When adversaries possess systems that jeopardize the survival of the CSG in high-threat environments, that condition ceases to exist. The phone call that used to be answered with, "We're sending an aircraft carrier," now carries an implicit qualification, under certain circumstances. And that qualification is exactly what adversaries needed to recalibrate their own plans. But is this restriction exclusive to Russia? Or is something bigger underway? The answer is no. Russia is not alone in this. China has developed in parallel a portfolio of anti-ship capabilities that altogether is arguably more concerning for American naval planning than the Zircon alone. The DF-21D, the so-called carrier killer, is a medium-range ballistic missile with an active terminal seeker, specifically designed to hit moving ships on the high seas, with a range of approximately 1,500 kilometers. The DF-26, nicknamed the Guam Killer, extends that range to 4,000 kilometers, putting any American base in the Western Pacific within reach. The YJ-18 is a supersonic anti-ship cruise missile launched from submarines with a flight profile that combines a cruise phase with a high-speed terminal dive. None of these are the Zircon, but together they cover multiple ranges, altitudes, speeds, and launch platforms in a way that no single defense architecture can adequately address. What this means is that two of the world's three greatest military powers, Russia and China, now simultaneously possess credible anti-ship capabilities that impose severe operational restrictions on American carrier strike groups. This isn't a single adversary's problem. It's a structural shift in the global security environment. The U.S. Navy recognizes this reality. The doctrine of distributed maritime operations, or DMO, is the doctrinal response. Instead of concentrating power around a single high-value asset like the aircraft carrier, DMO distributes lethal capacity across smaller and more numerous platforms, creating a diffuse targeting problem that is harder to saturate with high-cost missiles. The growing investment in submarines, long-range strike weapons, and unmanned systems, all of this is consistent with a Navy that is redesigning its operational doctrine for the world that exists right now. The aircraft carrier will remain indispensable. For operations in low to moderate threat environments, there is no substitute for its air projection and logistical capabilities. For conflicts against powers without advanced hypersonic capabilities, it remains the dominant instrument it has always been. But, as an opening instrument in a great power scenario, the first move any American president makes in a crisis with Russia or China, the aircraft carrier now carries an asterisk that didn't exist 15 years ago. 80 years. That's how long the American aircraft carrier reigned as the undisputed instrument of naval power. From the Battle of Midway in 1942 until the 2020s, no adversarial power had the credible and operational capability to jeopardize the survival of a carrier strike group in the open ocean. The Zircon doesn't end this era instantly. There is no single dramatic moment of rupture. What we see is a gradual but now documented and operational compression of the zones where the aircraft carrier can operate with unrestricted freedom of movement. A reduction in the strategic radius of action, not of the ship, but of the certainty it carried. 350 seconds don't sink an aircraft carrier. 350 seconds redraw the map of where an aircraft carrier can go. And that redrawing, not the sunken ship. But the contracted freedom of movement is the real story that begins with a number and ends with a geopolitical era coming to a close. That is the analysis strategists in Washington, Moscow, and Beijing are making right now. And now it's the analysis you have too. If this video changed how you think about naval power, American supremacy, and what happens when physics meets politics, leave a comment below with what surprised you the most. Hit the like button if you made it to the end. And if you want to keep getting this level of detailed analysis on the conflicts reshaping the world, subscribe to the channel.